In this video, we're going to talk about some of the other formulas that we'll find on that sheet, including two of the more difficult ones, the half angle and power reducing formulas. So first, looking at the half angle formulas, you're going to find those in the middle of your formula sheet on the right hand side. So you'll see one for the sine of u over 2, cosine of u over 2, and tangent of u over 2. When you look at those sine and cosine ones, you will notice that on the outside of that radical, you'll see a plus or minus. So what that's trying to communicate is that the formula itself cannot determine whether it should be a positive or a negative. So you are going to have to determine that based on which quadrant u over 2 will end up in. So typically you're going to be given an angle u, and then, or you may be given the u over 2, and then you'll have to figure out the u in order to use it in the formula. Let's see how this might work. So we're going to first look at the sine of 105 degrees, and we're going to do it two different ways. We'll do it first using our half angle formula, and then we'll do the same problem using our sum formula, and we'll get two very different answers, but if you plug them into your calculator, you'll see that they're actually the same number. They'll give you that same decimal. They just don't look very similar. So we're going to find the sine of 105 degrees first using a half angle. So that means we want to think of 105 degrees as half of some angle. So if you multiply the 105 by 2, then 210 divided by 2, 210 over 2, 210 divided by 2 is 105. So we can see that the sine of 105 will be the same as the sine of 210 degrees divided by 2. That allows us to use our formula that we get off the sheet for sine of u over 2, and it's going to be plus or minus. We'll have to determine which that is. We'll talk about that in a moment, of the square root of 1 minus cosine of u. Now notice, this u right here corresponds to this u in our formula, and this u over 2 right here corresponds to the 105 degrees. So when we are determining whether it's going to be a positive or a negative, we're going to use this angle. So 105 degrees we know is in quadrant 2, and the sine of an angle in quadrant 2 is going to be positive, and that is why we will choose the positive square root of 1 minus cosine u over 2. Now we will go to 1 minus the cosine of, and here's where we're going to use this angle, the 210. So, and then over 2. Now cosine of 210 we know, so that is in quadrant 3. So 210 degrees is in quadrant 3. Its reference angle here is 30 degrees. We know that the cosine of 30 degrees is square root of 3 over 2. And we also know that in quadrant 3, that's a negative. So we're going to get 1 minus a negative square root of 3 over 2, all in the radical. Okay, now we're going to have to do some pretty serious algebra here. So we are going to get a common denominator. So that's going to be 2 over 2 plus the square root of 3 over 2, all in the radical. So that's going to be 2 plus square root of 3 all over 2. To divide by this 2 is to multiply by a half. It's reciprocal. And so we're going to get 2 plus the square root of 3 all over 4. We can split up that radical and take the square root of 2 plus square root of 3 over the square root of 4, and simplify that square root of 4 in the denominator. And so our answer is kind of a strange looking number because we have a square root inside a square root here. That is going to be our answer. And remember, we decided that it was going to be a positive on the outside of that radical based on the fact that 105 degrees is in quadrant 2. Okay, now this is a little bit surprising and at first a little disconcerting, but we'll be able to resolve it. We can do sine of 105 degrees using our sum formula. And our sum formula is the sine of u plus v is sine cosine plus cosine sine. So that's going to give us the sine of 60 degrees times the cosine of 45 degrees plus the cosine of 60 degrees times the sine of 45 degrees. So the sine of 60 degrees is going to be square root of 3 over 2. The cosine of 45 degrees is the square root of 2 over 2. The cosine of 60 degrees is 1/2, and the sine of 45 degrees is square root of 2 over 2. We've seen this before. That's going to be the square root of 6 plus the square root of 2 all over 4. And at first glance, those don't look anything alike. But if you put each of those into your calculator, you will see they're actually the same decimal. All right, let's move on and see if we can do the cosine of 157 degrees 30 minutes. And so we want to see that this is half of, well, if we take 2 times 157 degrees 30 minutes, 2 times 157 is going to be 314 degrees. 2 times the 30 minutes makes that 60 minutes. 60 minutes is 1 degree, so that's going to be 315 degrees. So 157 degrees 30 minutes. Oops, I bumped the button there with my left hand. So 157 degrees 30 minutes we can think of as, keep hitting this with my left hand, it's going to be, and now I lost my pen, so that's going to be the cosine of 315 degrees divided by 2. So using our half angle formula that says the cosine of u over 2 will be plus or minus the square root of, I guess it's 1 plus cosine of u over 2. So remember, the plus or minus is going to be determined by what quadrant this angle is in, and then separate from that, we are going to say this u is going to be that angle that's being divided by 2. So 157 degrees, 30 minutes is in between 90 and 180. That's in quadrant 2, and a cosine in quadrant 2 is negative. That's typically one of the harder things to find in doing these half-angle problems. Now we're going to get 1 plus, that's going to be the cosine of 315 degrees, and we're going to divide that all by 2. So let's see, 315 degrees, the reference angle is 45. Cosine of 45 is square root of 2 over 2. 315 degrees is in quadrant 4, and cosine in quadrant 4 is positive. So now we got to do some algebra work here. That's 2 over 2 plus square root of 2 over 2 all over 2. I don't know how much room I left myself. I'm going to bring this coming back up here. So that's going to be 2 plus the square root of 2 all over 2. This 2 in the denominator, we're going to multiply by the reciprocal. That's still inside that radical, which we said was a negative. So that'll be a negative, and that's going to be 2 plus square root of 2 all over 4. We'll split that up and call it the square root of the numerator, 2 plus square root of 2 all over the square root of 4, which is 2, and that is going to be our answer. Okay, now the tangent of pi over 12, we're going to think of that as the tangent of, let's see, if we multiply 2 times pi over 12, that's going to be pi over 6. So that's pi over 6 divided by 2. So we have in our formula the tangent of u over 2. We have 2 different versions we can use, either the 1 minus cosine u over sine u or the sine u over 1 plus cosine u. I don't think it much matters. I'm just going to go with the first one, 1 minus cosine of u over the sine of u. So we are going to say our u is pi over 6. So that's going to be 1 minus the cosine of pi over 6 all over the sine of pi over 6. Cosine of pi over 6 is square root of 3 over 2, and the sine of pi over 6 is a half. Well, I think I chose wisely there. So in the numerator, we're going to get 2 over 2 minus the square root of 3 over 2. That's going to be all divided by a half. So that's going to be 2 minus square root of 3 all over 2. And then I'm going to multiply by the reciprocal. We'll be able to cancel those. And our final answer is going to be 2 minus the square root of 3. And on the tangent curve, on the tangent half angle formula, it will determine the sine for you. So that one, you don't have to make that call like you do with the sine and cosine formulas. Okay, now we're going to go to the product to sum formulas. So product to sum formulas are on the left side on the very bottom. Here we have a cosine times a cosine. If you look down at those, cosine times sine is the very last one. And the formula there says cosine u sine v is 1/2 times the sine of u plus v minus the sine of u minus v. So this 3 is just hanging out. So that 3 is going to multiply the 1/2 that comes from our formula. And then we're going to get the sine of u plus v is going to be 4x plus 5x. And the u minus v is going to be 4x minus 5x. So that looks like 3/2 times the sine of 9x minus the sine of 4x minus 5x is negative x. Now, I'm going to expect you to recognize that, remember, sine x is odd, so a sine of negative x is a negative sine x. Cosine x is even, so if you got a cosine of negative x, I would expect you to write it as just a cosine of x. So I'm going to expect you to bring that negative through because of the fact that sine is odd. And so we're going to say 3/2 sine of 9x, and that'll become a plus sine of x. That's going to be our final answer. Okay. Now the next one we have again this 6. Oh, I should say with this here we have a sine times a sine. And that looks like the very first formula. So in our formulas, we have the sine of u times the sine of v is 1/2 cosine of u minus v and minus cosine of u plus v. So for us, we're going to have that 6 hanging out. We'll get our 1/2. And then that's going to be the sine of 2x minus 3x, and then minus the cosine of 2x plus 3x. And so the 6 times the 2 will cancel. So we'll just get 3. And then here again, we're going to get a sine of negative x and a cosine of 5x. So we'll pull that negative through, and then just for aesthetics, and I guess I can't really do it. So I'll write it as a negative sine x minus cosine 5x. That would be fine. If you want, you could even pull that negative out, but that is just if you don't like to have all those negatives. Either of those is equally acceptable. Okay. Now going the other direction, we're going to go sum to products. So those sum to products are on the right on the very bottom. And so we see on the first one that we have a cosine plus a cosine. And so in our formula sheet, we have, let me write it as the cosine of u plus the cosine of v. And that looks like the third formula down is going to be 2 cosine of u plus v divided by 2 times the cosine of u minus v divided by 2. So for us, that's going to be 2 cosine of 195 plus 105 divided by 2 times the cosine of 195 minus 105 divided by 2. So that's going to be 2 cosine of, let's see, 5 plus the 195 makes that 200. So that, and another 100 makes that 300 over 2. And this one is going to be, see, 195 minus 105, I think is 90 divided by 2. So these are going to be known values. Here's 150 degrees, and this is 45 degrees. So we know that 150 degrees is in quadrant 2, and its reference angle is 30 degrees. The cosine of 30 degrees is square root of 3 over 2. In quadrant 2, that's going to be a negative square root of 3 over 2. Cosine of 45 is square root of 2 over 2. So we can cancel one of the 2's, and then negative 3 times negative square root of 3 times negative square root of 2 is going to be a negative square root of 6 over 2. There's our final answer. The next one, we have a cosine minus a cosine. So cosine u minus cosine v, that's our very bottom formula. So that's going to be a negative 2 sine of u plus v over 2 times the sine of u minus v over 2. So for us, that's going to be a negative 2 sine of, and we're going to get 165 plus 75 all over 2, and a sine of, let's see, 165 minus 75 all over 2. So let's see, 165 plus 75, that's 170 plus 70 is 240. 240 divided by 2 is 120. And 165 minus 75 is going to be 90. 90 divided by 2 is 45. So that's going to be a negative 2. Sine of 120 is going to be over here. The reference angle is going to be 60. And the sine of 60 is square root of 3 over 2. And in quadrant 2, sine is positive. And we know sine of 45 is square root of 2 over 2. So these are looking pretty similar. This is going to be a negative square root of 6 over 2. Okay. These are a little trickier, people. And the hard part is I won't warn you to use your formulas. So you're going to see here that you've got this equation, and you see that the angles don't match. So when that happens, we need to do something to resolve that. We need for these to be the same angle. And so we don't have any formula for the sine of 3x to make it into sine of x's like we do a double angle formula. So instead, we're going to look for our sum to product formulas, because we want to make these be multiplying each other. So if we go to sum to product, we can see that sine u plus sine v, according to that formula, is going to be 2 sine of u plus v divided by 2 times the cosine of u minus v divided by 2. So we can then make this into 2 sine of, that's going to be a 3x plus x divided by 2 times a cosine of 3x minus x divided by 2. And remember, that's still equal to 0. So 4x divided by 2 is 2x. Cosine of, and that's going to be 2x divided by 2 is just x equals 0. Now this is an improvement over where we were because these are multiplying each other. So we can divide by the 2. That's not really going to affect anything. But now that we have two things being multiplied that equal 0, we can set each of these equal to 0. Now remember, our domain was 0 to 2 pi. This is our double angle. We've seen this before. So if x is between 0 and 2 pi, then if we multiply through by 2, we can see that 2x will go all the way to 4 pi. So we're going to say, what are the angles that make sine equal to 0 in between 0 and 4 pi? Well, sine is 0 at multiples of pi. So that's going to be 0, pi, 2 pi, 3 pi, and then we have a strict inequality, so we're not going to include 4 pi. Then we'll divide through by 2, and so we will get x is equal to 0, pi over 2, pi, and 3 pi over 2. Notice these are all between 0 and 2 pi. Now we're going to do the cosine part, but this is just x, so we're just between 0 and 2 pi, and the places where cosine is 0 are pi over 2 and 3 pi over 2, but they're already listed down below, so we haven't gained anything new, and that makes this the solution set. Okay? Let's try it with this cosine minus a cosine. So our sum to product formulas say that the cosine of u minus the cosine of v, that's our last formula on the bottom there, is negative 2 sine of u plus v divided by 2 times the sine of u minus v divided by 2. So we're going to get a negative 2, and then it's going to be a sine of, and then we're going to have 2x, oops, I left off the x. Let's say 2x plus 4x divided by 2 times a sine of, and then we have 2x minus 4x divided by 2, and that we want equal to 0. So we have negative 2 sine of 6x divided by 2 is 3x times the sine of 2x minus 4x is negative 2x. Negative 2x divided by 2 is a negative x. Now we can divide this negative 2 out because that's still going to be 0. Then we can say sine 3x is equal to 0. Now remember, the sine is an odd function, so we can make that be a negative sine x equals 0 and divide by the negative 1, and so that negative really doesn't affect anything. We just still have sine x equals 0. So remember, x is going from 0 to 2 pi, which means for 3x, we want to go all the way to 6 pi. So we're going to have 3x is going to go all the way to 6 pi, 3 times around the circle. Sine is equal to 0 at multiples of pi, so that's going to be 0, and pi is 1 trip around the circle. 2 pi and 3 pi is the second trip, and then 4 pi and 5 pi take us around the circle the third time. We'll divide by 3, and so we're going to get 0, pi over 3, 2 pi over 3, 3 pi over 3 is just pi, 4 pi over 3, and 5 pi over 3, just as a check. Notice that last one is still less than 2 pi. Now, from sine x, we just get 0 and pi, because we're only going one time around the circle, since that's just a 1x, but the 0 and pi have already been named, so we haven't gained anything, and these 6 answers are the answers we're after. Now, this is another, half angles and power reducing formulas are the hardest ones. So, and this is hard to understand why we would even want to do this, but this will become more clear in calculus. Actually, we do this more in BC calculus. But at some point in time, we may be asked to find an integral of sine 4x. And for reasons that we'll understand better down the road, that may be hard to do. I'm sorry, this is going to be a, I didn't write that right. Let me fix that. That's a sine to the fourth of x. So we want to reduce the powers so that we have only first powers, and in exchange what we'll get is maybe a sine of 2x or a cosine of 3x or something like that, something that has what we call multiple angles. So, but the idea is if it's a first power, it's going to be much easier to do calculus with. That's the basic idea. So what we're going to do is we're going to say sine to the fourth is the same thing as sine squared x times sine squared x. Now our power reducing formula, if you find that it's in the middle on the left side there, sine squared of u is going to be 1 minus cosine of 2x all over 2, or use whatever you want to call them. So each of these sine squares are going to get replaced by a 1 minus cosine 2x over 2. So this is progress, but as we're going to see, this isn't going to be the end of the story, not by a long shot. We're going to multiply those denominators, and I'm just going to call those 1/4 rather than leaving them as a big fraction. In the numerator, we're going to have to square that out. So when we multiply that, we're going to get the first one squared. Let me write that in the middle more. First one squared twice the product is going to be a negative 2 cosine of 2x, plus the second one squared is going to be a cosine squared 2x. Now we still have something that's not a first power. So what we have to do here is go back to our power reducing formula, and now we're going to say that the cosine squared, I'm going to go back to calling these u's because I'm going to say we have a different u than just plain x. Now our u is 2x, so we're going to get, and I didn't write that as a u after I said I was going to, so we're going to get the 1 minus cosine 2u is going to be that cosine of that 2x, so that's going to become 1 minus, that's a sine, sorry, cosine. The cosine of 2u's is 1 plus. Okay, let me get the formula right. How about cosine squared of u is 1 plus cosine 2u over 2. So our u is going to be that 2x. That's right here. And then we're going to get 2 times that is going to make that a 1 plus cosine 4x all over 2. Okay, I hope that made sense. Now I'm going to factor this 1/2, but I'm going to have to factor it out of everything. So we factor out that 1/2, that's now a 1/8. When you factor out a 1/2, you're dividing by a half. When you divide by a half, you're going to multiply by 2. So that's going to become 2. That's going to become 4 cosine of 2x. And now that we've taken care of that denominator, we have a plus 1 plus cosine 4x. Now a final minor cleanup. The 2 and the 1 will combine to be 3 minus 4 cosine 2x plus cosine 4x. Now I know that looks a lot worse than where we started, but to a calculus student, this is actually much, much easier to work with than will that. But you're going to have to wait a while to really appreciate it. Okay, let's look at the sine squared times cosine squared. So we have one of each here. So the sine squared x, we're going to call 1 minus cosine of 2x all over 2. And the cosine squared is going to be 1 plus cosine of 2x all over 2. So I like to, again, just take the denominator and make that a 1/4. When we multiply those, we get the difference of 2 squares, which is going to be 1 minus cosine squared 2x. So not quite as complicated as we were before. Again, we're not going to stop because we've got a cosine squared. So this will now become 1/4 times 1 minus, and this cosine squared of u is going to, now our u here is going to be our 2x, so we're going to get 1 plus cosine of 4x all over 2, so we've introduced into the fraction 1/2. So this 2 will factor out as a 1/2, makes that 1/8. This must be also have that 1/2 factored out, which will make it now be a 2. This negative sign has to distribute, so that's going to be a -1 minus cosine of 4x, and with a little bit of cleanup, we're going to get the 2 minus 1 is 1 minus cosine of 4x. That's the end of our story. All right, so like I said, the half angles and the power reducing, they're going to be challenging.